All right, welcome everybody. Let's do this. So, lesson 26, extra support. The idea for today is a few days ago we practiced factoring skills on this page. So for this video, I'm not going to go over the factoring skills. What I want you to do is go to this page over here with question 7, and it says level 1. And the idea is we're going to be practicing how to solve rational equations. Okay? So let's look at the first question. The idea is, how can we solve for x over here? How do we get x by itself? And the idea is, so when we talk about strategy, we always want the denominators to be the same. So 1, denominators to be the same, okay? And one other thing we need to focus on is, notice that you see how here it says we have x minus 3 in the denominator. Notice that x cannot equal 3, because if we substitute 3 in here, the whole thing becomes 0. And what is 1 divided by 0? If you say 0, that's wrong. Remember, anything divided by 0 is undefined. So just one small little note, x cannot equal 3. When you look at, let's say, look at number 8. What can x not equal over here? X cannot equal 5. Okay? So let's look at number 1 again. So the idea is, how do we get the denominators to be the same? Notice that if the least common denominator is x minus 3. So notice how you have an x minus 3 here, you have an x minus 3 here, but then you have this minus 1 over here, which looks a little weird. So how do you actually change this minus 1 so it has some x minus 3 on the denominator? And all you need to understand, like, all it is notice that 1 is equal to x minus 3 over x minus 3. Because if you have something divided by the same thing, it equals 1. Okay? And that's the little trick over here, that you know that 1 is equal to something divided by the same thing. So you're going to change this 1 into x minus 3 over x minus 3. So then here, we're just going to rewrite the problem. So this is 1 over x minus 3 minus x minus 3 over x minus 3 equals negative 3x over x minus 3. Okay? Now, we accomplished the part of getting the denominators to be the same, but why did we want the denominators to be the same? Because we talked about in the previous lesson that if the denominators are the same, then you're allowed to cross out all the denominators and say that the numerators are equal. Okay? So the next move you're allowed to do is you're allowed to say 1 minus x minus 3 equals negative 3x. Now, this is where I see a lot of students make mistakes. So I purposely did this because this is not 100% correct. Because if you do this, you're forgetting that this minus 1 needs to be distributed to the x and to the minus 3. So be very careful that you have to put a parentheses over here. Okay? Now we solve for x. Okay? So what I want you to do is pause the video and try and solve for x. Okay? So how would you solve for x over here? Well, this becomes 1. Now we need to distribute the negative, right? So this becomes negative x plus 3 equals negative 3x. You see, if you didn't have the parentheses, then this would have been negative 3, and this would have been incorrect. Okay? So how do you get x by itself over here? Well, okay, let's combine terms. So this is 4 minus x equals negative 3x. Then what do you do over here? Remember, anytime I'm doing this, always try and pause the video and see what you think you would do, and then see if it was the right move or not. Because if you just copy what I'm doing, you're not really learning. You got to try and don't be afraid to make mistakes, right? So what's the next move here? We do plus x, and now here this becomes 4 equals negative 2x. And now once you have 4 equals negative 2x, You divide by -2, divide by -2, so x is equal to -2. And then you ask yourself, once you get to this point, is x allowed to be -2? Yes. X can be any number except 3. Okay? So x equals -2 is okay. All right? And that's how we solve the first one. Try and solve this one, right? And the idea is you want all the denominators to be the same, right? So notice that you see this 7 is also equal to, how can you change this 7 so it has some x minus 5 on the bottom, right? The idea is you're allowed to do this. 7 is equal to 7 times x minus 5 over x minus 5, okay? Now, why are you allowed to do that? Because notice, what is this equal to? This is equal to 1. So what is 1 times anything? It's the same thing. So that's the idea for this. And if I want, I could just put a negative here as well. It doesn't make a difference. So now here, the way you change it is -7 times x minus 5 over x minus 5 minus 5x over x minus 5 equals -1 over x minus 5. Okay? Pause the video and try and solve it. Okay? Because of time, I'm going to go a little bit fast. Okay? So here, all the denominators are the same, so we're allowed to cancel them out. Here, now we just have -7 times x minus 5 minus, and what I want you to do is anytime you see a minus, let's just put a parentheses here, just so you don't make a careless mistake. And then here, this is -7x plus 35 minus 5x equals -1. So then how do you get x by itself? What's the next move? Let's combine these two, so you get -12x plus 35 equals -1, minus 35 minus 35, so -12x is equal to -36. Divide by -12, divide by -12, x equals 3. And you have to ask yourself, is x allowed to be 3? Yes. Remember, x cannot be 5. Okay? I hope this helped, and this is just a warm-up. Try and do level 2. Let's do level 2 very quickly. The idea for the level 2 over here is, notice that you have x plus 1 and x plus 1. You want this x to somehow have some x plus 1 on the denominator, and the trick for this, that notice that x is the same as x times x plus 1 over x plus 1, okay? Because notice, what is x plus 1 over x plus 1? This is equal to 1. What is 1 times x? It's still x. And that's how you change this x so that it has an x plus 1 on the bottom. So this becomes x times x plus 1 over x plus 1 minus 2 over x plus 1 equals 2x over x plus 1. Okay? What I want you to do is pause the video and try and do this yourself. Don't just keep going and me doing all the work, right? Okay, so now the denominators are the same, so that means the numerators are equal. So now I have x times x plus 1 minus 2 equals 2x. Now I have x squared plus x minus 2 equals 2x. Now the idea for this is, once we have a x squared or quadratic, how do we solve for x? And we've talked about this. How do you solve for x here? What I want you to do is pause the video and think about it. How do you solve for x? We want 0 on one side. And why do we want 0? Well, it'll be very clear very soon, but here notice that you have x squared plus x minus 2 equals 2x. And then how do you get 0 on one side? Okay, well, let's do minus 2x minus 2x. And now here, this becomes x squared minus x minus 2 equals 0. So now that we have 0, what was the purpose of getting 0 on one side once we have a quadratic or some x squared? pause the video and try and answer that question without me going. But the idea is we want to factor. What two numbers, when you multiply, give you -2, but when you add, give you -1? Pause the video and try and figure that out. Notice that it's x minus 2, x plus 1 equals 0. All right, and then here, once we get to this, once we have x minus 2 times x plus 1 equals 0, notice that x equals 2, right, and x equals -1. But the idea is, once you get to this, notice, you see how before, when we had here, what can x not be? X cannot be 3. Because if you put 3 in the 3 minus 3 is 0, and you're not allowed to have 1 over 0, that's undefined. Here, x cannot be 5. Here, here, what can x not equal? X cannot equal -1. Because if you plug in -1, you get something over 0, and that's undefined. So notice that for the two solutions, we got x equals 2 and x equals -1. We say that this is an extraneous solution because you're not allowed to have -1 as one of your answers. So then you have to use this one, that x equals 2 is a solution for this quadratic. Okay? I hope this helped. Try and do the next part by yourself. I'll see you in class.